Test. Good morning, everyone. Welcome to another episode of Xah Talk Show. Today I'm going to teach you Emacs regular expressions. Okay, I'm going to teach you Emacs regular expressions for the first 30 minutes or so. 30 minutes, 40 minutes. Then perhaps we are going to chat randomly about things, about programming things, JavaScript, Golang, programming languages, and so on. Maybe after that. But first of all, I'm going to give you a introduction. Maybe a bit deeper than introduction. If you are Emacs user, I'm going to explain and teach you about Emacs regular expression. But officially, this video is supposed to start in 7 more minutes. So actually, I will be back. So people can get on. I start early, so start at 5 p.m. San Francisco time. Okay, that's in 7 minutes. Okay, so yeah, let that be that. So I hope people come on to my live stream. And today's topic is Emacs regular expression. Yep. Okay. Now see you in 5 minutes. Okay, now it's 4:58. So welcome to another episode of Xah Talk Show. Today is August 4th, and 2019, 5 o'clock p.m. And we are going to teach Emacs regular expressions and possibly some Emacs Lisp. So as usual, type your comments, your thoughts. Say hi. Type where you're from. That way, the talk gets better. Typically, the more people talk, we get. I get more topics to talk. I get more relaxed, and it's and people get. When people see other people type stuff, then they start to type too. So things get busy, which is good for us. So I'm going to teach about Emacs regular expressions. Okay, shall we begin? Let's see. Two people watching. So let's make the windows over here so you can see. And let's move the windows over here. Now on my Emacs, my Emacs window, there are two windows here on the left. You can see every commands I call. Forward word, backward word, cursor up, previous line, cursor down. Every command, basically every command, delete, things like that. You will see it. So when you see something I'm doing, you are not sure exactly what, you can look up the command name. Typically it's on my website, so you can get a code to use for yourself. Okay, so let's talk about Emacs regular expressions. Now, Emacs regular expressions, as you know, regular expressions is a way for you to pattern match strings, text, text like that. For example, let's say I want to find, this is my Emacs blog, this file, HTML file showing browser. So you can see this is my Emacs blog, lots of pages. And suppose I want to find or mention of the word Haskell, I can call the command. Let's see what the command, list matching lines. Okay, list matching lines, Haskell. I type Haskell, press enter. None found, so there's no word Haskell. Let's type subscribe, SUBS. Okay, one occurrence. Let's try to find archive. Okay, two occurrence. But let's say I want to find any words beginning with AR and ending with a E. So let's do that. AR dot plus E space. Okay, now the dot means any character, so it's a wild card. Like in poker games or some card games, it's called wild card. So the dot matches any character, and a plus sign means one or more occurrence of whatever pattern before that. So here, a dot plus means one or more characters. So we have AR dot plus E and space. That will find any word. Okay, let's put a space in front. So any word beginning with AR and ends with E. Let's see what we get. Okay, so we got several. So we got article, we got article, we got arguments. Oh, actually, this matches a lot of things. And then we got array-like object, curly quote. So it actually tried to match a sentence. You see this sentence, array-like object Emacs curly quote. They began with AR and ends with E. So that is the pattern space AR dot plus E space. Now you see, we don't want, for example, we don't want sentences. We just want words. So we can do what we can do is let's try to do it again. So list matching lines. Then the pattern will be. Let me give you the pattern. Okay. Okay. So hold on a second. Okay. AR square bracket. Then A dash Z. Then after that a plus sign. So what this means is that we are going to find any pattern that begin with a space A R, then any character, any one of A to Z, the alphabet. Then plus means one or more of it. Then end with E, then space. So this should give us all words that begin with AR and ends with E. So let's try it. Indeed, we got article. So why is not archive not part of it? Because archive here begin with a capital letter. So if we want also capital letters, we can see we can do it like that. We can okay. Okay. So capital letters, we can do it this way. Let's see. We're gonna okay, square bracket A and capital A and lowercase a. Okay. Oops. Hold on a second. Capital A and lowercase a. Okay, let's try it. So we still only get article. So why is not archive part of it? Let's try it again. So space capital A lowercase a R. Then we have a space after that. Let's remove that space. Okay, so we got that. So we got archive, article, argument. So that is illustration, an example of using regular expression. You see, so regular expression is a way to capture patterns, patterns in text or string. Now, I guess most of you are already familiar with regular expressions, just in case you are not. Okay, so let's get on to the Emacs regular expression. So in programming languages, Perl, Python, Ruby, Java, JavaScript, almost basically Golang, every language has regular expression built in. In Emacs, of course, you have that too, but notice that each programming language, their regular expression syntax is a little bit different. Basically they are all the same, but sometimes a little bit different. Now for Emacs regular expression in Emacs regular expression is particularly different from the other languages. So if you program Perl, Python, Ruby, PHP, Java, JavaScript, their expression, you could say they are all the same. Okay, they are like 99% the same. You know one, you know them all. But in Emacs, it's like 90% is the same, but the rest 10% is a bit different. So what is the major difference? Let me talk about that just a little bit. Just so for you guys already know regular expression in other languages, you can immediately see what's the Emacs regular expression difference. So okay, let me talk about that. Let me just say okay, so actually let me type the topics we are talking so that we have a sense of what we've talked about. So example of regular regex use, we already covered that example of regular expression. Then we talked about we were using list matching lines. So the command is list matching lines, mx list matching lines. Okay, so we've tried, we've demonstrated that in Emacs list matching lines command is a great way in Emacs to learn regular expression, because whenever you want to learn the syntax of regular expression in Emacs, you can always just use call list matching lines and give a pattern. That's a great way to learn regular expression. This command is a great way to test learn regex in Emacs. Okay, so we covered example use of regular expression. Let's talk about difference between Emacs regex and other language regex. Regex are all similar in Perl, Python, Ruby, PHP, Java, JavaScript, Act. Okay, but Emacs regex is slightly more different. Okay, Emacs regex is slightly more different. The difference between Emacs regex and other language regex. Okay, so so what is the difference between Emacs regular expression and others? Basically, so in other regular expression, you have \d that stand for digits, okay, and \w stand for word. You know, basically any A to Z, and digits. Okay, so in other regular expressions you have that, but in Emacs regular expression you do not have that. You do not have \d. You do not have \w. Actually, in Emacs regular expression you do have \w, but however the meaning is slightly different from the other regular expression. Okay, so so we are trying to say the major difference between Emacs regex and other land regex are so that and that. Actually, I have that written out somewhere, so let's see, where is that? Hey guys, hey, Xdoc Prince, not a touch typist, so Emacs default are fine with me. What do you mean? You mean the key binding? So yeah, we're talking about Emacs regular expression. So what's the major difference between Emacs regex and other line regex? Let me show you. I covered that somewhere here. Okay, okay, here. So you see JavaScript versus Emacs regex. Now JavaScript regular expression is pretty similar to Perl, Python, Ruby, PHP, Java. Okay, they are all similar. So JavaScript versus Emacs regex. So yeah, so here are the major differences. So you have, so in other languages, when you want to capture, you use parentheses, but in Emacs regular expression, you have to \parentheses. You know, the parenthesis character is literal in Emacs. Then we talked about you have digits, you have words, you have white space, \s for white space in other languages, but in Emacs you don't have that. So in Emacs, if you want to do that, you have to use these syntax like double square bracket, then colon digit colon. Okay, similarly for word and space, you have to type the word space. So anyway, so this is for those of you already know regular expression. So I'm trying to show the major differences, but I'm going to explain more in detail using Emacs regex. So if you don't know regex already, that's okay. We're gonna talk about it. These are just the major differences between Emacs and the others. Okay, so now let's get back to talk about Emacs regular expression, how we use it, and so on. So first of all, list matching lines is a great command to try it. Okay, so if you have Emacs, if you are in front of a computer, try it. Just call list matching lines. For you can open any file, any buffer, create a new file, then start to type something you try to match. For example, like email. Then you call list matching lines. List matching lines. List matching lines. You call it. Let's say dot at dot. Then it will pop up result in the in another pane, split pane. Okay, so that's and another great command to test regular expression is query replace regex. Now this command actually have a key binding. Let's see what it is. Now guys, type your comments and thoughts. Okay, let's get the chat lively. So another command great to call is query regex. Query replace regex. Now what that command does is that it allows you to do find and replace in the current buffer using regular expression. So let's demonstrate that. So let's say I want to replace the word atom. Let's say I want to replace the word article to archive. Let's say, for example. So we can do. Let me get the regex ready here. So okay, so what we can do. So let's say replace the word article to archive in this buffer. Wait, that's not a good example. Let's try email. So because email is a commonly used pattern people want to do. So let's say xah at gmail.com. Let's say joe at gmail.com. Let's say rand at live.com. Okay, some random name. So we have several email addresses, and we want to replace let's say replace the .com to let's say this is .org. Okay, so we have a bunch of email addresses. We want to replace the .org or .net into something else, .net. So let's say gen outpost.net. Okay, several random email addresses. We want to, let's say, replace all the suffix to or .com. Let's say, so we can say query replace regex. Okay. Okay, so I just call the command query replace regex, and type a pattern. Let's say dot plus. Dot means any character, plus means one or more, then @ sign, then anything not dot. Okay, this pattern is getting complex. Regular expression syntax is such that it takes some time to understand them. Hey, good morning, Bartholomew. Regular expression takes some time to get familiar. So if you are not quite getting it, don't worry, because it took me several years. I've been using regular expression for more than 20 years now. So, but I do remember in the beginning, first few years, it's always like confusing. Like like sometimes you want to replace something, you tried many patterns many times and take hours, it doesn't work. So it takes time to get to know them well. Okay, so right now we are trying to match the email addresses. And so what pattern to do to use that? So one way we can do is this. You know, so if you don't know what I'm doing, that's okay. Eventually you will. I'm just going to do it for now. Okay. So let's say so the pattern we want is that this will be literal dot, then dot dot dot. Okay, let's say 3 words. Yeah, okay. um, Wait, actually this will be this will be more complicated than I thought. Okay, so let's say that dot plus. So I think this pattern will work. Let's try that. So actually I'm going to explain in a bit. Okay, so let's do query replace regex. Let me call the command query replace regex, type the pattern. Okay, that is the pattern we want. Actually we need more than that. Actually, so we need so when you see this, you might think, oh my god, this is so complicated, I'll never learn regular expression. Regular expression is tremendously powerful. Like if you work in any job, like even if you go to job interview, often they'll ask you, how well you know regular expressions. So you want to really know them well because it's tremendously useful. So let me try to finish this pattern. Okay, so I'm going to need that plus sign. Okay, so this is the pattern that will match email like this. Okay, so let's try that. Copy that, and let's call query replace regex. Well, first of all, let's do list matching lines. Remember that's a great command to test regular expressions. So let's test it first. So let's call list matching lines. Give the pattern. Let's see what it finds. Okay, it found tons of things. So that means our pattern is too general. This is not good. Oh yeah, so actually, okay, so let's try that again. A to Z, A to Z. Okay, let's try that again. Then A to Z. Okay, so then A to Z. Okay. Okay, so let's try that again. List matching lines. We give a pattern. There it is. Fantastic. Don't you think this is fantastic? We have you see, we want to get all email addresses in this file. This file has 900 lines, and now we just call one command and we got all the email addresses listed here. So this is wonderful. So now if we want to replace part of it, we can now try the query replace regex. So let me show you. So let's call query regex replace. I have a keyboard shortcut that calls the command. You can see the command on the left panel. Okay, now I need to give a pattern. So pattern will be that. And what do you want to replace it with? Let's say we just want to replace like this is a email address. Okay, this is done. So we just replace with the text. This is an email address. Okay, let's say okay. Okay, so it found one occurrence. It's going to ask you what you want to do about it. You can replace it. You can skip it and go to the next match. And Emacs will say type question for help. There are several shortcut keys you can oops shortcut. So let's do it again. So query replace rejects use this pattern and replaced by that text. Say yes. I can say yes, 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 yes. That replace them all. Now let's try one more thing. Okay, let's do query replace rejects. The beginning pattern will be the same as we used before. Let's see. Yeah, this pattern. So let's use that pattern. And let's say the ending pattern will be \1. \1 means the first captured item. You'll see what it means. Let me show you. So, okay. So, yes, 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 yes. You see? So, what it does is that it replaces the whole email address by just the first name. The beginning part of the email address. So you see now how regular expression is used, and that also demonstrates the power of regular expression. So regular expression can be used to find find any text patterns you want. For example, in programming language, when you code what you want to refactor, find function names, replace with something else, or find variables names, or find some a universal ID, or encrypted key. They usually have certain pattern. You can find them all, and you can also do replace. So that demonstrates the power and one example usage of regular expression. And now let me explain the syntax of regular expression. Now this is the part that you really want to learn. Okay, so but let me write down what we have just done. Demo the power and example of regex use. Okay, for example, finding email addresses in a file. Okay, we have shown that example. Okay, then this is the pattern used. Okay, this is the regex pattern used. Now you can see in browser, so we have written out what we were doing. So okay, we have demonstrated the example of usage of regular expression. Now let's talk about the syntax of regex. That is the heart of the thing. When you learn regex, it's about the syntax. So let's see. Let me read the comments. Hey, Deck Ways. Good morning. Oh, good evening. So Bartholomew says, yes, regex seems complicated at first, but you just need to learn it and understand how it works. Yes, exactly. Be persistent. Then it becomes very powerful. Yes, exactly. So Deckway says, regex is up. We use it at work to tokenize documents for further processing. Yeah, yes, yeah. It's interesting, the history of regular expression. The name regular expression. It's kind of silly. It's like regular expression. First of all, you don't think in programming languages when you see the word expression, you don't think you like expression has a value, right, in programming languages. But this regular expression, it doesn't look like an expression. Then it says regular. What the heck? It's not regular. I mean, look at the syntax. It's not in any way it doesn't come to mind. It's regular. The reason it's called regular expression is historical. It's very complicated. It's rather very complicated. But basically, it came from the study of theoretical computer science, study on parsing. Also, part of it is known as automata, like automata, and basically it's study parsing. Okay, like given a bunch of it study formal it's part of the formal language originally. Regular expression, they came up because originally it's part of the theoretical. This is important. Theoretical computer science, not related to anything practical. It's related to theoretical computer science on the in the branch of formal languages. What they are trying to do is that they are trying to find a way, a syntax kind of, to match, to be able to pass or match any so-called regular languages. That is a language with regular grammar. Okay, so that is why it's called regular expression. Because it's supposed to be able to match any computer language whose grammar is called regular grammar. Now, regular grammar, the word itself is very confusing because the regular grammar and regular languages, they are in no way regular in a daily English sense. They are not regular. Okay, so anyway, it's convoluted history. So regular expression. So actually, let me show you some articles about that if you are interested. So Xah automata and Xah parser compiler. Okay, so these are interesting things you might look into. Um, how compiler works. Okay, that's part of it. So I have this tutorial that is a introduction, a really truly basic introduction about how compiler works. Now, if you read this, you will begin to learn, how compiler works. Like this is not in depth. This just give you an intro idea, like what exactly compilers do. And then if you read it, you'll learn parsing. Parsing. What does it mean for a programming language to parse the language? Then you also learn about grammar. A grammar of a programming language. How is it defined? Exactly what it is. Then you'll also learn about Backus null form, which is a standard it's a syntax to specify programming language grammar. Now, once you know that, then you'll learn about regular grammar. One of the class of grammar is called regular. So languages with regular grammar is called regular languages. Then you also learn, you hear often context-free languages. That is also a very confusing jargon because it is not in the normal English word context-free. When you have a context-free language, it actually doesn't mean it's context-free. It means it has specific meaning. So anyway, you'll learn about regular languages. Then you'll learn about context-free grammar. Then you'll learn about regular expression. This is when regular expression come up because it tries to match all regular languages. So anyway, you can read that. But there's another interesting thing about regular expression. That is, when you read about regular expression, you will often come to the term automata. Again, this is very confusing, and it has very interesting history and linguistics as well. So why do they call it automata? Finite state automata and so on. And automata, this is very interesting. I digressed. We're gonna get back to Emacs, okay, practical tutorial in a bit. But automata basically means a machine, okay. It's ancient. It's like 2,000 years ago. This guy from Greek mythology Talos. His name is Talos. He is a automata. Now, automata, what does it mean? It just means a robot. So back in the Greek mythology days, so you have this guy Talos. He's a automata. He's a giant, mecha. If you watch Japanese anime, it's a kind of like a mecha back in 2,000 years ago. So automata means just means like a machine that operate by itself. It doesn't need human input. It doesn't need someone to tell him. It's not like remote controls or anything. It controls itself. That's automata. Then in computer science they started to call um, something, they call it automata, which is kind of bad naming, because in no way it's self-operating. So anyway, it's complicated, linguistic and very interesting history about how this word came to be. So let's go back to regular expression. So we talked about so there's a common question about, like for beginners, when they learn regular expression, they have a common question. So what's the difference between wildcards? Like in file names, for example, in Unix, you have this wildcard, asterisk sign, which stand for any sequence of characters. Then the question mark stand for any character, one single character, stand for any character. Then, so in Unix, for example, you can do that. uh, let's say open in terminal. Okay, let me open my current directory in terminal. So I'm here. So let's do ls. Okay, ls, this is a Unix. Let me move this up so you can see. So you see, so I'm listing directories, ls. So let's say ls asterisk el. That will list any file name ending in el. Okay, let's try it. You see, that's this wildcard. By the way, this wildcard is called glob. This wildcard system of matching text patterns is called glob. It's came from the Unix jargon. It's called glob. So this is glob, and it's also in Windows. You can also do that in Windows. So when people learn regular expression, they think, I already know glob. Why do I need regular expression? It seems more complicated. The thing is, so glob, so you have these patterns. It's not very flexible. So when you, for example, you cannot use glob to, for example, to catch or email patterns, because yeah, because if you use glob, you'll get bunch of text. That's not email. It's not powerful enough. That is why you need to learn and use regular expressions. They serve kind of the same purpose, but the glob is very simple. It's just for very simple. Regular expression is the far more powerful one. So I give some examples where you can use regular expression to match something, but globs just cannot do. And okay, so let's talk about some common patterns for regular expression. So these are the most frequently used patterns. And that basically, that's about okay, something else. I'll talk about using regular expression in Emacs. Let me read the comments first. So Deckways says, today I wrote some Java bytecode. Reminded me of learning assembly compiler act in university. So Bartholomew says, minor note, I think the singular is automaton, while the plural is automata. You are right. Yeah. So yeah, correction. You are right. Singular is automaton. That's that word is just so interesting to me. And Xdoc Prince says there is no God, but Emacs and Stallman is his prophet. Okay. Okay, so let's talk about Emacs Regex syntax. So I give some patterns. These are the most commonly used. So so if you want to learn regex, you can start with these patterns. Now it's hard to read them out. It's hard to read the regular expression syntax. So for those of you not watching the video, you just have to actually go to my website and look at these patterns. So yeah, so these are the common, most frequently used patterns. So when you want to, again, as I mentioned, you can just try list matching lines and try the patterns, and you can see, you will understand what they match. They, for example, they do one or more digits, one or more non-digit characters, one or more letters, one or more letters, digits, or hyphen, or one or more letter digit underscore, or one or more letter digit hyphen underscore. That's all common. Then you can also match all ASCII characters. Then you can also match all non-ASCII characters. For example, you have a emoji. Let's try that. So for example, let's match. So in this my Emacs blog, this is 1,000 lines. I want to get all characters that's not ASCII. For example, I have some emoji characters or arrow, math summation or arrow symbols. I want to get all of them, see what they are. So I call list matching lines, and I give this double bracket, then colon, then I say non-ASCII. Okay, let's see if I got the syntax correct. Yeah, okay. So I do that, and with a so double square bracket, then two colons, then inside that you say non-ASCII. Okay, this pattern will match any one non-ASCII character. So then I put a plus sign. Oops. Okay, let's do it again. Right, let's do it again. Non-ASCII. Then I type a plus sign, means one or more of it. Okay, let's say enter. Okay, so you can see the result. Let's magnify. You see, I have quite a few. I have quite a few Unicode here. So we have the ellipsis, we have the curly quote, we have the bell symbol for YouTube subscribe and bell, alert. We have runes, the rune, Asian rune alphabet, and we have the Unicode Z symbol, which stand for what is Z for? Natural number integers, I think. And we have the summation sign, we have the copyright sign. So this is how useful is the Unicode, is how useful is the regular expression. You can match all these kind of things, and you cannot do with the wildcard, the glob. So okay, these are the common patterns in regular expression. Okay, one more thing I want to mention is how do you match a return character or tab character in Emacs. To do that, in Emacs you cannot use the \n. Okay, like if you came from other programming languages, you call list matching lines and then you say \n. That doesn't work. So instead, to enter a literal new line character, to match your new line, you have to type Control Q, then return. So Control Q, enter. That's how you type. So let me show an example. so let's say I want to okay, so let's say I want to match, let's say list matching lines. Okay, I call list matching lines, you can see on the left, list matching lines. Then I say that less equals to less than, okay, then I type less than sign slash code greater than sign, so that matches the code tag, the ending code tag. Then I type control Q, enter. Wait. Oh, wait. I got this wrong actually. Let's do it again. Um, list matching lines code. Then control Q, control J. Okay. Okay, my tutorial is actually incorrect. Oh my god, shit. For years, this I got this incorrect information. So actually, you need to type Control Q, Control J. Okay. Okay, Control Q, Control J. That will actually insert a new line character. Then I type that. Okay, that will match any occurrences of, let's do it. Enter. It'll match any occurrences of these. There's only one occurrence, you see. So anyway, the point is, when you want a new line character, you have to type Control Q, Control J. Now, why is that? Well, it's because it's a bit complicated. It's because Emacs key syntax, history of Emacs key syntax. I have an article explaining that. But anyway, let me go fix my article. Control Q, Control J. Okay, so that's what you need to do. So for several years I got this wrong because I kept updating my articles like every 2 years, like hundreds of articles, and I try to rephrase it, try to improve it. It's rather very tedious work. So anyway, that's the corrected that. So anyway, so I actually that's about it for Emacs regular expression. Okay, yeah. So I've been talking for like 50 minutes. That's a good. Yeah. So I don't think we're gonna talk about. So that's about the main thing. There are other things like case. How do you control case sensitivity? Uh, there are other things, but I think it's nice to stop here because we don't want to get too much and too long. If you like, you can read my Emacs tutorial, which gives you information in detail. Let me type it here. And let's read the comments and let's just chat randomly for 5 minutes or something. Any questions, comments, opinions, type it. Okay. So let's see. Minor. No, so there is no God but Emacs and installment. Okay. So there's no more comments. So far so good. So anything else? So guys comments. Okay, so oops, I don't want to pause. So let me go around. So Bartholomew is from Germany. Now Germany is right now. Oh, it's like 3 o'clock in the morning. Wow. And the Deckways. Were you from Deckways? I forgot. And were you from Dark Prince? Ruby operators. Yeah. So can you? So Deckways says, can you take a look at Ruby operators? Well, hold on a second. I'm not very familiar with Ruby, and I haven't done Ruby for, I only spent 2 months studying it, and that was like 4 years ago, basically 4 or 5 years ago. Well, beginning in 2012. So operators in Ruby. Oh, Deckways is also from Germany. Oh, you two are friends, is that right? Bartholomew and Deckways. I am using a ad blocker. You see, right now you are seeing Google Chrome, which I actually don't use much. But basically, when you use Google services, you have to use Google Chrome, kind of, because Google has become so evil that they, if you use other browsers, often it fails and stuff. Um, since I'm doing YouTube, which is Google's account, so so that's why I'm using Google Chrome. But normally, my main browser is the Brave browser, and also Firefox browser, also Safari. Actually, I use them all, for different purposes. Brave is a browser that's based on Google Chromium, and it has the ad blocking built in. It's a new kind of system. So, and in Firefox, I have JavaScript off. That so when you have JavaScript off, that that makes everything much safer, even safer than ad blockers. Because when JavaScript is off, websites can hardly do anything. All the viruses and malware, they don't work. But when JavaScript off, most websites will be not readable. They come up empty, or things are getting bad, like that. So what about um, Ruby operators? So what do you want to talk about? Like, I don't know. Like, I don't even know what are the Ruby operators. Like, so I remember, if I recall correctly, a few days ago, you were saying they are confusing, right? Yes, I think you were saying they are confusing or something like that. But I don't really know Ruby, right? Right? Takeaways. Uh, Anything else? Answer. Like, so what's about Ruby? So Deckway says they have single symbol operators for many things, like private. Oh, that. Okay, that is not. I don't think they are operators. They are the. Let's see, Ruby variables. Let's see, where is this? True false list, hash table function map. Yeah, so Ruby. Let's go to Ruby basics. Printing strings, coding strings, string manipulation, numbers and string conversion. Everything is a object. Variables. Yeah, so Ruby variables, you have these condition. You have this syntactical markup, basically. Uh, I have a article about that. Let's see. Where is it? Oh yeah. So Lisa. Wait. So you have a bunch of predefined variables. Now, Ruby has a bunch of predefined global variables. They all start with a dollar sign. Uh, but the thing we are talking, oh, here. So variable name prefix and variable scope. So Ruby has follows this compiler enforced syntactical rule about variable names. So if it starts with a dollar sign, its scope is global. It's a global variable. If it starts with a @sign, then it's a instance variable of a class. If it starts with a double @sign, then it's a class variable. So that's part of the syntax. It's not a operator, I don't think. So so they have single symbol operators for many things like private, public, yes. And I think actually, in my personal opinion about programming language design, so these are actually called sigil. Perl began with a name. They are called sigil. Okay, and I have strong opinions about that. Actually, I think that's a great thing. Let's see, Xah sigil wall. I actually have a quite a few articles about that. Um, because I think it's a good thing because let me I don't know if you are interested in that, but probably because this is an interesting topic about programming language design. Okay, let me talk about that. I want to build my own keypad, have a keyboard. Okay, we got a lot of topics. uh, I think they are okay. No, I think they are great. Maybe I can let me explain my view. Okay, so maybe you'll maybe you'll think about maybe possibly you'll change your mind. You know, like how we have functional program. We have strongly typed languages. For example, Java, C, C++, Golang, Haskell, especially Haskell or Camel. They are strongly typed. And in functional programming, like Haskell, F Sharp, or Camel, they have type inference, which is like a fancy mechanism to infer types. So basically, if you are in a Haskell community, they have a strong concept about like type solves everything. Like like type they type prevents many errors and can be useful as part of your program to actually specify things and in many ways prevent error. So anyway, so that's a point about strongly typed languages. The idea is that types prevents many errors. Everything is like strict. They like almost like they follow a logic types. Now now note that these strongly typed languages type the concept. They are semantic concept. They are not syntax. They are semantic. Like for example, you declare a variable type int. So this variable is a type integer. Like the compiler will understand it. It has a meaning. Semantic. The type concept is semantic. Now, what if you can turn that concept into syntax? So whenever, for example, let's go back to Ruby. Maybe you don't like Ruby, but in Ruby, for example, whenever you see a variable name start with a dollar sign, you know immediately that this is a global variable. It has a global scope. So what I'm saying is that the semantic, the meaning, of the type, which is the typed languages, semantic. Now it becomes syntactical, which is great because you look at things, you already know what it means. So when you have a when you have a @ sign, already it's a instance variable. When you have double at sign, you know it's a class variable. So by looking at things, even without compiling, like two humans, you already know what it means. But compiler also know what it means. Like compiler, when the compiler sees a dollar sign in front of variable, it knows, like because of the definition of the language, it already knows this is a global variable. So you see what I mean? So this so it so we with this sigil thing, it kind of turns the semantic concept of types into a syntactic concept. That is critical because in formal languages, when you study formal languages, which is the basically the foundation of theoretical computer science, which is where regular expression came from, automata, or the regular languages, context-free grammar, they are all formal languages. Now, what is a formal language? Formal language is basically just a bunch of characters, like no meaning, no semantic meaning. A formal language, study of formal language is purely just sequence of characters. How can they be changed? How can they be transformed? That's it. That's why you define a language using the formal language grammar. That's all. That's what formal language is about. Just a bunch of characters, sequence of characters, or you call it a string. A sequence of characters. So what I'm saying here is that so now you turn the type concept into a for example, like Ruby, it becomes a syntactical concept. So you can actually treat it as a formal language. So that's my idea. That's what I'm saying. So in other words, for example, let's say we invent a new language. Now every suppose every function name start with f. Let's not say f. Let's say lambda. Okay. Now, if you create a language where every identifier, if the identifier start with a lambda, it means a function. Or in other words, every time you define a function, the compiler enforce that the name must start with a lambda. That's a similar idea with a sigil. This idea is called sigil. Okay, sigil. Okay. So if you have that wouldn't that be great? Because now, especially in JavaScript, especially in many of these flexible syntax languages like Ruby, JavaScript, where a function can be a value, it can be assigned to a variable. You get confused because a variable can be a function, can be lots of things. But now if every function name start with the lambda, that kind of clarifies. So that is why I think this sigil idea, turning semantic concept of type into a syntactic concept or formal languages, is a great thing. Now, actually, we have also other conventions. We are already doing that. For example, Ruby is one example. Another example is, let me show you. Naming a predicate. Okay, computer language, predicate function, terminology, and naming convention. Now, in Emacs Lisp, if a function ends with a P, that means the function returns either true or false. That's a Emacs Lisp convention. Now, in Closure Lisp and Scheme Lisp, when a function ends with a question mark, that means the function always returns true or false. This is another idea of sigil. Where you specify the meaning in the syntax itself. And I'm giving some examples. So Emacs Lisp ending with P, Scheme and Closure ends with a question sign. Same thing with Ruby. Ruby also ends with if a function ends with a question sign, it means it returns true or false. Okay. In Wolfram language, Mathematica, it ends with a capital Q. Q stands for question. So here, these are some conventions, and Ruby too. Here are a list of names in Ruby functions. Zero question mark, odd question mark, even question mark, integer question mark, non-zero question mark. You have lots of these function names. So this is another idea of the sigil, where you turn the concept of type from semantics to syntax. So I think, so in my opinion, I think this is great. Now, let me also mention that in Perl, you also have sigil, but Perl sigil is entirely different from this idea, because Perl sigil depends on value. So it's kind of different, okay? But let's not, get into that. So this is the idea of the sigil. So I have some articles discussing the pros and cons of sigil in detail. Sigil for function parameter names. I want functional parameters. I want to be able to, when in a programming language, you have variables. You have global variables, you have function parameters, and you have local variables. I want to be able to distinguish them syntactically. By looking at it, I know this variable is local variable, or it's a function parameter, or it's a global variable. Now I know of no languages that has this, where it distinguish functions parameter variable by syntactically by a sigil. I don't know any of that. But I did create my own convention. I experimented for a while. I think it's good. So anyway, so that's some of the ideas about sigil. So that's why I think it's a good thing. That's about that. Deckway says, every time I look at Ruby code I wrote a couple of weeks ago, I need to look up what all the symbols mean. Yeah, that's a valid reason, but that also applies to almost every aspect of programming language. For example, in C, for example, in Lisp. In Lisp, everything is parentheses. You don't have to remember about the syntax. But in C, unless you already program in C for years. But if you are a new programmer, you look at the syntax, like each one is different, and no regularity. Like you have to remember, oh, this is loop. Loop needs to be this way. So anyone can make the same complaint about C syntax, which is actually about the whole language. So that's uh, okay. So let's see. Yeah, so you are saying, you have to learn what the sigils means, but I don't think you know, that's valid. I mean, it's valid criticism, but for example, in math, you have plus sign, multiply, divide. You have to learn that too, and equal. The reason they are not confusing is only because you've been using them for years. That is actually the reason. You don't have to remember what the plus sign means. And then there's the power sign, and and square root and so on. So there's a something to be said about familiarity. Because these math symbols, you are so used to them since you are age 5 to kindergarten. That is why nobody complains, but doesn't mean that these are actually intuitive. So familiarity is a great thing. It's a big thing in everything we do. So in C, because every language is based on C. Why? Because the moment they create some new syntax, people don't like it, because most people already familiar with C. That is why C syntax grows and grows. C, C++, Java, Golang, JavaScript. Like almost every language is C syntax. and almost nobody complains only because we are so used to it. But if you actually look from the beginner, point of view, C syntax is the worst because everything is, special. Every syntax is special. There's no, it's not systematic. In other words, it's not systematic. So when it comes to, Ruby sigil, or, like for example, let me show you another example. Go closure. Okay. Typically in Lisp, we have the convention where, uh, let's go to closure. Okay, let's go to my closure tutorial. Closure has a lot of these magic characters, very annoying. Like you can complain about Ruby. Wait until you code closure. Closure, is one of the Lisp branch of Lisp family, but one thing unique about closure is that closure, they created this whole bunch, like tens of them, of these special cryptic short operator kind of thing, like to be part of the function name. Like in traditional Lisp, Emacs Lisp, Scheme Lisp, Racket, Common Lisp, there is a convention where you avoid, any of the abbreviations. Like typically, you function name is like full function name by traditionally. Typically you rarely see abbreviations, but closure is like 180 degrees turnaround of that concept. Closure, they love, the Rich Hickey. He created this bunch of like things, with these special characters in function name to indicate, different meaning, particular semantic to that function name function. Then you have then their function tends to be abbreviated like 4 letters, 3 characters, 4 characters. So wait until you decode closure. That's more confusing. uh, so okay, so I think that's about it for today, because it's been like yeah, so yeah, an hour and 20 minutes. So that's it for today. Anything else? So so Bartholomew, so I think there is a question. I remember what I wanted to tell you. I want to build my own keypad, half of a keyboard basically. Your website was partly responsible for inspiration. Great, thank you regarding this. Thank you. Yeah, so let's talk about keyboard some other time. Today it's too already kind of too long. Um, so how is your web server set up to your website? I think I talked about that for 5 minutes yesterday or the day before. Maybe we can talk about that. It's not much. I'm old school. I just use async. I can show you actually. So close this. For example, let's close Ruby. For example, my Emacs block. I can sync to my web server by going to eShell, then just call async. Okay, then that syncs up to my server. Now, if you go to my web server, Xah Emacs blog, you'll see today's update. This is temporary. I'm going to remove them and stuff later. So no, you don't know what it means. So I read. So you have to learn and connect them in your head. Yes. Okay, yeah. Hope to see you guys soon. If you like my stuff, you can go to you can support me via, you know, Patreon, Amazon gift card, PayPal, and stuff. By the way, if you use Amazon gift card, use this link, okay? Because sometimes I got people. There are a couple of people from Italy, or from French. They use Amazon Italy, but I cannot cache that. Yeah, so if you want to support me or buy my Emacs tutorial. So thank you guys for watching. See you soon.